Let's talk about the derivative of exponential functions. So at the top of the page here, you can see our two derivative rules for exponential. So some number raised to the x power. So what typically comes first is that we see that e to the x is its own derivative. So we have d dx of e to the x, so derivative of e to the x is itself. And then we also have kind of the larger rule that takes care of every other exponential and actually includes this as well. So for anything that's like 2 to the x, 10 to the x, 4 to the x, any number raised to the x, our derivative rule will be that same function again, e to the x, times the natural log of the base number. And this does also cover the rule for e to the x, but if we put e to the x into this formula, we would have e to the x ln of e. And the ln of e is the exponent e needs to get to e, which is just 1. So this simplifies down to e to the x, which agrees with this rule here. All right, let's do some examples and see these derivative rules in action. The first example I have here is just a straightforward use of the rules to get used to them. So for this function f of x, its derivative will be separate derivative problem plus separate because they're added. 10 times the derivative rule for e to the x, so that's also e to the x. And then for the other two, we switch to this rule over here. So 2 to the x's derivative is 2 to the x ln of 2. And 3 to the x's derivative is 3 to the x ln of 3. All right, let's see this rule kind of mixed up into different derivative rules. So here we have a product rule, and later we'll see the chain. So this next function is 3 to the x times x cubed. So this doesn't overall have its own derivative rule. So then we switch to thinking, is this put together by multiplication, division, composition? And we see that this is a product, right? There's multiplication between these two functions. So I'm going to have product rule where f is 3 to the x and g is x cubed. And I intentionally put these two functions together because they look so much alike, and we use two completely different derivative rules in this step for them. So for f, we have 3 to the x, where the x is the exponent position. That makes it one of these new exponentials that uses this here. So we'll again have 3 to the x ln of 3. And then for g, we have x to the third power. So the x, the variable is the base of the exponential, whereas over here it was the exponent. This makes it a completely different function type. This uses the power rule that we had earlier. So its derivative would be 3x squared. Once I put all of that together in the product rule, I have my final answer. So I'll have f prime g plus g prime f. F prime g plus g prime f. All right, so my last two examples in this video, you can see on the screen now. They're both going to employ the chain rule to differentiate. And I wanted to kind of emphasize how composition looks when it involves an exponential function. At least to me, it just kind of always looks a little bit weird. So I wanted to make sure we got some extra practice. All right, so we want to see this as f of g of x and use the chain rule. All right, so the outer function f of x here is no longer really like the outermost operation, right? Like we don't have parentheses to an exponent. We don't have like a big square root over everything, but we have e to the stuff. So if this is going to be f of g of x, the f would have been e to the x, and the g is 5x plus 1, right? So if I plug this in for x in here, I get this function. Now I can go about doing the rest of the scratch work and put all these together into the chain rule formula f prime of g times g prime. So my final answer here is f prime of g times g prime. You can put the times 5 at the end, or if you think it looks better, you can also put that times 5 at the beginning right here. All All right, this last one is also a chain rule. And again, I'm doing similar problems just to kind of emphasize what composition looks like when it has an exponential function in it like this. So again, it's a little bit tougher to suss out what the outer operation f and the inner function g is. Here, 3 to the x is the outer function f, and root x is what's being plugged into it, right? So if we plugged this in for x right here, we would have our original formula. So this will be my f and g. Each of them is a derivative rule. We have 3 to the x ln of 3, and then 1/2 x to the negative 1/2. And then one more time, I'll put them together into the chain rule formula for my final answer. All right, so I have f prime of g. So I'm going to have this whole formula, but just this x up in the air, I'm going to fill in with root x. So this is f prime of g, and then times g prime. Puts a 1/2 x to the negative 1/2 at the end.